Hello friends, I am Sound Pfeffer and I welcome you all for the second lecture series of assignment problem. Today we are going to discuss about unbalanced type of assignment problem. So before that I would suggest if you haven't gone through my first lecture then kindly go through that first lecture series of assignment problem. Link for the same is also given here. So in that lecture we have already discussed how to solve assignment problem by using a algorithm, Hungarian Assignment Method. And we have already also discussed how this specially structured linear program is differ from transportation problem and what are the different methods that can be used to solve this. So in addition to that, I would also like to mention that this is another variant of transportation problem in which we can solve this very easily by using a Hungarian assignment method. So we are not ep- employing transportation algorithm here. So there are many reasons that we have discussed. Apart from that, one more reason I would like to discuss today is that in transportation problem, as we know, we required number of allocation is m plus n minus 1. So these are the number of allocation required to proceed with the transportation algorithm for any m cross n matrix. Okay, while if we discuss assignment problem, so in assignment problem we have number of row equal to number of column. So here m equal to n. Okay, so in assignment problem m is number of row equal to number of column. So matrix is we can consider n cross n, and number of allocation required as a assignment is 1-to-1 basis. So we required one job for one worker. So obviously for n cross n matrix the number of allocation we required is n only. Okay, so if you compare this with this transportation requirement of transportation, so you will observe that to proceed with transportation algorithm, instead of n allocation we have to go with m plus n minus 1 allocation. So it means that this n allocation will not work. So to reach up to m plus n minus 1 allocation we need to add certain number of epsilon that we have already done in transportation problem degeneracy case. So that kind of similar situation you can consider and you can add the number of epsilon to reach the number of allocation that will be equal to m plus n minus 1, and then you can proceed with transportation algorithm to solve assignment problem. Okay, so obviously with increasing matrix size this number of epsilon need to be added will also increase, and that will also increase the number of calculations that to be proceed with transportation algorithm. So it is obvious choice to go with Hungarian assignment method, which is quite easy and friendly to use. So here again we are going to discuss about how this harm method can be employed for unbalanced type problem. So here example 2, as you can read the given data. So as you can see in this example, different persons along with the different kinds of job are given in matrix which indicating a payoff matrix. It means the person P1 take 27 rupees for performing this J1 job J1. If person P1 assigned this job then it will cost 18 rupees. Likewise different prices are indicated here. So our task is to assign it is in optimal way which results into a minimum assignment cost. Okay, so you can see there are certain cross mark here. It means this person cannot perform this job. That's why it is cross marked here. Similarly, this person cannot perform this job. So for that cross mark, we have put a high value, high cost to perform this particular job. So obviously, this cannot be assigned to this person as we have done in BGM method for LPB. Okay. So in such cases, we are assigning a very large value. M means very big value that preventing to assign this particular job to that person. Okay. Now you can observe the number of rows and column in this example is not same, so it is unbalanced. So number of column are 5 and number of rows we have is 4. So proceed with assignment algorithm, we need number of row equal to number of column. So in this case we have to add one dummy row to make it balanced, and then we can proceed with algorithm of assignment problem. So we rewriting this table and making it balanced. So as you can see, we have added one dummy row. Okay, and rest of the matrix is as it is. Now we proceed with Hungarian assignment model. So as per the Hungarian assignment model, as we know, first of all we produce a reduced cost table by row minima. So for each row we taking the minimum value and subtracting it from each row. Okay. So for starting with this first row, the minimum value available with us is 18. So we'll deduct this 18 in this first row and making a new calculations. Okay, so 27 minus 18, that will be result into 9. 18 minus 18 equal to 0. This will remain as it is, which is very large value, so it will not going to change this m. 20 minus 18, that will be equal to 2. 21 minus 18, that will be equal to 3. Similarly for second row, the minimum value available with us in second row is 12. So we'll deduct this 12 from each cell of second row. So starting with this, 31 minus 12 equal to 19. 24 minus 12 equal to 12. 21 minus 12, that will be equal to 9. 12 minus 12 is 0. 17 minus 12, 5. Similarly for the third row, the minimum value we have is 16. So we'll reduce 16 from each element of third row. So 20 minus 16 equal to 4. 17 minus 16, 1. 20 minus 16, 4. M will be as it is and this will be 0. So again for the fourth row, the minimum value we have is 16. So we'll reduce 16 from each element of fourth row. So 22 minus 16, that will be equal to 6. 28 minus 16, that will be equal to 12. 20 minus 16, 4 and 0. 27 minus 16, that will be equal to 11. Here the minimum value we have is 0, and when we reduce 0 from each element it will be 0. So no change in this row. So we have this reduced table 1. This is reduced cost table by row minima. Now we will proceed for column minima. So similar operation we will perform for each column. So here you will observe for this column minimum value is 0. So when we subtract 0 from each element of this first column, the value will remain unchanged. It will be as it is. Similarly for this column also, the minimum value available is 0. So obviously for every column we have minimum value 0. So this table will remain unchanged. So our second step is also fulfilled. Now we will proceed for third step of Hungarian assignment method. In third step, we draw a minimum number of lines that will cover all zeros. Okay, so we'll draw a line in such a manner that which will cover maximum number of zero. Okay, so maximum number of zero available is in this row. So we'll first draw line for this, and this is striked out. Next line we can draw for the maximum number of zero available is in this column. Okay, and next line we have for this zero and for this zero. So the number of line, as you can see, are 1, 2, 3 and 4. So number of lines are not equal to the matrix. The matrix is 5 by 5 and number of lines we have is 4. So as per the algorithm, we need modification in this table, and again we need to draw a number of lines. Okay, so what modification required is we need to find out the minimum value from uncovered cells. So from these uncovered values, the minimum value we have is 4. So we need to subtract this 4 from each uncovered value, and this need to be added at junctions value. So wherever two lines has been crossed, two or more number of lines has been crossed, at that point we are going to add this 4, and remaining value which covered by line will be as it is. Okay, so only junction point will be added with this 4, and remaining value which are underlying this line will be as it is. Okay, and all uncovered cells will be subtracted with this 4. Okay, so let's start with this 5 will become 1. You have to rewrite this in next table. 9 minus 4 equal to 5, 12 minus 4 equal to 8, 19 minus 4 that will be equal to 15. This 6 minus 4 equal to 2, 12 minus 4 equal to 8, this will be 0. Then 11 minus 4 equal to 7. Okay, now we are going to add this 4 at our junction. This junction will be changed to 2 plus 4 equal to 6. This junction m plus 4 equal to m. Obviously m is very large value, it will not going to change, so it will remain unaffected. So next junction we have this, so this 0 will become 4. Okay, so I am clearing all this line, and we will again find out the number of lines that can be drawn. So we are making the number of lines again and check. So number of maximum 0 available here. So first line is completed. Second maximum number of 0 available is in this row. Okay, next 0 we have in this, next this one. Okay, so all zeros are again covered, and the number of lines we have is again 1, 2, 3, 4. Since the matrix is 5 by 5, sorry, one more 0 is left here. So yes, now we have number of lines 1, 2, 3, 4, 5. So number of lines are matching with our matrix, so no further modification required in this case. If this wasn't matching, then again we need to perform the similar operation that we have performed just now. Okay, so that is iteration need to be performed again and again until you will reach to the number of lines equal to the matrix size. So for n by n matrix, the number of lines should be equal to n. Okay, now this condition has been matched, and now we can proceed with the allocation. So to proceed with the allocation, the rule is you start allocation with the minimum number of zero available in row. So this first row having a only single zero, so we can allocate over here, and the remaining zero in that particular line, sorry, in particular column is cancelled out. Okay, column or row. Now again we will calculate the number of minimum zero available again in this second row, only single zero, and remaining zero we can cancel out in that particular column or row. Okay, next allocation we can made is in this row, so only single zero available, and we can cancel out remaining zero in that particular column and row. Clear? Now we have next available zero is this one, only single zero in this row, since this one is cancelled out, so allocation can be made here, and this zero in this column can be cancelled out. Now we will move further. In fifth row we have left with only this zero, so allocation can be made here. So now we have final answer along with our allocation. Now we need to transfer this allocation to our original matrix, and we can calculate the total assignment cost that is occurred for this assignment. So let's move to our original matrix with this allocation answer. So allocation that we have obtained for our original matrix, we can write the answer is P1, person P1 is assigned with job J2. Then next, so at the bottom you can observe the as per the allocation we have obtained the total cost. So in this original matrix we have put at the allocation that we have obtained, and this is our final cost. As you can observe, the allocation we have put it over here is 1 2 3 4. The fifth allocation as per the answer is P5J1. That cannot be included here as the P5 was a dummy row. So it means that the job 1 is remain unassigned. So rest of the jobs are assigned, only J1 is remain unassigned, and the total cost for the assignment of this remaining job are 66. Okay, and this is our final answer. I hope all of you have got how to solve unbalanced type assignment problem. Thank you all.